Good morning and welcome to week 11. All right, so we have a lot of concepts happening this week. If you remember Algebra 1, pre-algebra, Algebra 2 from maybe back in high school, you're probably familiar with a lot of these concepts. So hopefully we can pull from some of your prior knowledge. If not, I've done a few examples of each type of concept that you'll be seeing in your ALEKS homework this week. So hopefully we can get you up to speed. So we're going to start off pretty basic with just investigating the coordinate plane. So there's some things you should know about the coordinate plane. It has an x-axis. And please forward through this if you already know this. It's got a y-axis. There's a center. That center is called the origin. Okay. Now there's an infinite amount of points on a coordinate plane. And so we're going to pinpoint some points that are on this coordinate plane. Just keep in mind there's an infinite amount, and we're just going to try to find a few. You need 2 points to graph a line, which is what we're going to be doing this week. To graph a line, you need to find 2 points. And also you should be aware that the coordinate plane is split into 4 sections called quadrants. So this is quadrant 1. It kind of goes backwards. Quadrant 2, quadrant 3, and down here is quadrant 4. So 4 quadrants. Okay, so I'm going to start off by just plotting a point, right? So I'm going to plot a point, and usually points are always given in what's called coordinate form. So it's called coordinate form. And it's always move on the x, then move on the y. So the x-axis is that horizontal axis. That's horizontal. And the y-axis is your vertical. All right, so I'm going to plot the point 2, 3. Okay, so how do you plot the point? You always start at the origin. All right, we're going to start at the origin. Then, if we're going to plot 2, 3, we're going to move right 2 places. Then we're going to go up 3 places. So move right 2 places, then go up 3 places. So if I start at the origin, I'm going to move to +2, so 1, 2, and then up to +3, 1, 2, 3. So this is the point 2, 3. So if I start at the origin, I came over right 1, 2, and up +3, 1, 2, 3. Now I'm going to plot another point. Let's go for -4, 6. All right. So remember, this is your moving x. This is your moving on your y. So you're moving horizontally, then you're going to move vertically. All right. And something to kind of note, when you're here at the origin, everything to the right is positive x values. Everything to the left is negative. When you're moving on the y-axis, everything above the origin is positive. Everything below the origin is negative. So I'm going to start at the origin, and I'm going to move to -4 on the x-axis, which means I'm going to go left 1, 2, 3, 4. That's down to -4. And I'm going to go up +6. So down 1, 2, 3, -4, up +6. 1, 2, 3, 4, 5, 6. Okay, so -4, -1, -2, -3, -4, up to +6. 1, 2, 3, 4, 5, 6. So that is -4, 6. So notice when I plotted 2, 3, I was in the first quadrant. -4, 6 is in the second quadrant. Then you can Use like a debit card or something if you want to connect these 2 points, and you can connect them and make a line. Okay. Remember, lines go on infinite directions, so it's going to keep going that way and keep going this way infinitely. And it's going to hit so many points. Think about all those points it's going to hit along the way as it travels. Okay. We just identified 2 points. So that's sort of an introduction to the coordinate plane, or a refresher. So I made myself some notes here that make sure you know where the origin is, that it's got 4 quadrants, 1, 2, 3, 4. Okay, these are all Roman numerals. You always have XY coordinates. X is horizontal axis, Y is the vertical axis. And keep in mind, lines have infinite solutions. Now, these are the 2 formats you'll see lines written in. You'll see it in Y equals MX plus B format. You'll also see it in AX plus BY equals C format. So depending upon these different formats is how we're going to attack graphing the line. So these are 2 ways to write a line. 2 ways to write a line. Okay. And sometimes they call it a linear equation. So a line is part of that. All right, so let's jump into what you're going to be facing in ALEKS. Off we go. So we're going to start off with finding a solution to a linear equation in 2 variables. Find an ordered pair xy that is a solution to this equation. X minus 2y equals 4. So here's my hint. When possible, choose 0 to substitute into one of the unknown variables, and then solve for the other unknown variable. Remember that lines have infinite solutions or ordered pairs. You just need to find 2 coordinate pairs. So in this case, we're going to, I'm going to make a little chart, probably going to do that for most of these problems, an XY like little table. And here's what this is kind of saying to us. Some number X minus 2 times some number Y would be equal to 4. So these are 2 unknowns. So this is an unknown. And this is an unknown. And it would be some unknown number X, some unknown number X minus 2 times some unknown number Y would be equal to 4. Would be equal to the number 4. We got to figure out, at least they want us to find out 1 ordered pair. If you want to draw a line, we would need 2 ordered pairs. So for this particular case, we're going to find 2. You only have to really find 1, but for this particular question in ALEKS, but let's find 2. Okay, so when possible, here's my hint, choose 0. So if you think about your XY coordinate plane, you want to choose some X values that are right around the origin. So maybe 0. Maybe you could choose, 1 for X. Maybe you could choose 2 for X. You want to pick low values of X that are right around where you could see it on the graph. Okay. So, and we'll just probably just choose 2 of these. Okay, so we're going to substitute for X, we're going to substitute 0 into this equation. So instead of using X, I'm going to replace it with 0 minus 2y equals 4. Okay, so now you can say to yourself, 0 minus 2 times what number would be equal to 4? And you might be thinking, well, negative 2 times negative 2 is equal to 4, so I know that's going to be a negative 2. If you can't see that, then you can always solve this algebraically. You could skip the 0, because that kind of cancels out that X. Just write this as negative 2y equals 4. And we want to know what this y is, but negative 2 is multiplying. So to undo multiplication in algebra with an algebraic equation, we have an equal sign here, just divide. And make sure you do it on both sides. So -2 divided by -2 cancels, leaving you y equals whatever 4 divided by -2 is, which is -2. So there we have one solution. We could try putting a 2 in, right? Let's try putting a 2 in for x. So instead of x, we're going to replace it with a 2. So 2 minus 2y equals 4. This gets a little more tougher because you have to think of 2 minus 2 times some number would be equal to 4. So I'm going to solve this algebraically. So because it's an equal sign, we know this is an equation. I'm going to take this 2 that's positive. I'm just going to subtract it because 2 minus 2 cancels out. Bring down what's left. -2y equals 4 minus 2 is 2. Then I want to know what y is. I'm looking for y. What's y? -2 is multiplying to y, so I'm going to divide that out on both sides. Because -2 divided by -2 leaves me 1y, and 2 divided by -2 leaves me -1. So y is equal to -1. So we actually found two solutions. I didn't even try putting a 1 in there. But if we wanted to graph these, 0, -2 would be move 0 on the x-axis and drop down to -2 on the y. And then move 2 on the x-axis, 1, 2, and drop down to -1. Okay, so we've actually done more than what the problem is asking us for. We've actually figured out 2 points, okay? But in this particular case, they're just asking you to find one solution. So you can just give them 0, -2 as one solution, or another solution would be 2 and -1. Okay, so let's try that again. So pause the video, see what you can do with this one. Finding a solution to a linear equation in 2 variables. Find an ordered pair xy that is a solution to this equation. So they're asking us 6 times some unknown number minus some unknown number would be equal to 0. Figure out what that x and y are. All right, so pause the video, see what you can do. I'm going to take my own hint and put 0 into the x right here. So I'm going to write this as 6 times 0 minus y equals 6. So I love using zeros because they, in the previous example, when you put 0 in for x, right, it just sort of went away. At least it did there. Over here, when you put a 0 in for x, 6 times 0 becomes nothing. So this becomes 0 minus y equals 6. Well, you don't even really need that 0. You can just rewrite this as -y equals 6. And you don't really want -y, so there's really a -1 there. So if you think about -1 trying to multiply to y, let's divide that out. So -1 divided by -1 cancels, but you got to do it on the other sides. So y is equal to whatever 6 divided by -1 is, which is -6. So now we have found, one solution. So one solution could be 0, -6. And you don't have to do this on this problem, but let's graph it. So we're going to move 0 on the x, but we're going to drop down to 1, 2, 3, 4, 5, -6 here. Okay. Let's try putting a 1 in for x. All right, so let's put a 1 in for x. 6 times 1 minus y equals 6. Let's rewrite this. 6 times 1 is 6 minus y equals 6. This 6 is a positive 6. Let's move him over here to try to get y by itself. So that's what we're looking for is y. So because it's a positive 6, I'm going to subtract it, which cancels it. -y equals whatever 6 minus 6 is, which we know is 0. Remember, this negative is just a -1. And so it's -1 is trying to multiply to this number. Let's get rid of it by dividing. You always undo multiplication with division. So -1 divided by -1 cancels out, leaving us y equals. Well, if you divide on this side of the equal sign, you got to divide on the at side of the equal sign, and 0 divided by -1 is still 0. So your other coordinate could be 1, 0. Let's graph that just for giggles. So start at the origin, move on the x-axis to 1, and then we're not going to move anywhere on the y-axis, so we're going to stay right there. So we actually have graphed a line. So again, we're doing more than this problem requires, but I'm trying to just pull all this together so you can kind of see the total picture here. With this particular problem, you could just say, look, I think one of my solutions to this line, one of the coordinates that lay on this line, one of these infinite number of coordinates is 0, -6. All right, let's move to the next concept. All right, now they're going to give us a line in the equation of the form y equals mx. So they're giving us y equals 4x. Again, just think about this as y is some unknown number is equal to 4 times some unknown number. So they want us to graph, which means we need to find 2 points, which is fine. We're going to go back to our table. Okay. My hint to you is always, if you can, try to put 0 in for x, because you want to try to stick close to somewhere around this origin. So you could try putting 0 in for x. You could try putting any number here. Maybe I wouldn't go into the negative numbers. I would stay positive. So maybe you could put like a 1 or a 2 in for x. All right. So maybe we'll try a 1. Okay. So we're going to substitute in 0 for x. So y is equal to 4 times 0. Well, this is kind of nice. 4 times 0 is just 0. So y is equal to 0. Well, that's one coordinate. That's the actual origin. That line runs right through that origin. Let's try putting a 1 in for x. So now we'll try putting a 1 in for x. Y is equal to 4 times 1. Well, 4 times 1 is just 4. So y equals 4. So there's your other coordinate. So we're going to graph 0, 0, and 1, 4. So there's 0, 0. You know, you move 0 on the x and 0 on the y. And then we're going to move 1 on the x and up to positive 4 on the y. So 1, 2, 3, 4. So now you'll take your tool. In ALEKS, I think they let you plot 2 points, and then you grab like the little graphing line, little tool, and you'll just graph a line right through those 2 points. Okay, I'm going to have you try one on your own. Try this one, y equals -2x. So pause the video and see what you can do with this one. Okay, if you're back, I'm going to try substituting a 0 in for x first. 0 is my favorite number when it comes to graphing. If you put a 0 in there, you found out that y is equal to -2 times 0, which is 0. So this equation also goes through the origin at 0, 0. If you put a 1 in there, you could have put a 2 in there, you could have put a 3 in there. You want to stay low. All right, so -2 times 1. Well, that means y is equal to whatever -2 times 1 is, which is -2. So that's what y is equal to. So we're going to graph the coordinate 0, 0, which is that origin, and 1, -2. Okay, so this one is move 1 on the x, but go down on the y, -2. All right, we have 2 points, 0, 0, and 1, -2. So we're just going to connect the dots. And there's a graphing tool on ALEKS that will help you with that. All right, let's keep going. Graph the line y equals 1/2 x. Okay, well, we might have to get a little more crafty with this one because there's a fraction in here. But that's okay, we're going to sort this out. Okay, my hint always works. Always put a 0 in for x if you can. All right, usually it makes things nice and neatly packaged. So y equals 1/2 times, we're putting the 0 in for x, 0. Well, anything times 0 is what? It's 0. I love that. So this line actually goes through the origin. Now, when you have a fraction, you have to be a little more strategic about what number you want to put in. I'm going to show you why. What if you put a 1 in for x? Y equals 1/2 times 1. Well, then a half times 1 is just a half. I don't want to graph a half. I don't want to figure out where a half is in here. I want a nice solid number. So I don't want to use 1. So here's my hint. Whatever the denominator is, so if you have a fraction, choose the denominator as your x coordinate. To substitute in. So the denominator is a 2. So I'm going to try putting a 2 in for x. All right, so let's try that. Let's try my trick. So y equals 1/2 times 2. All right, well, what's a half of 2? Well, we know it's 1. If you think about this as fractions being multiplied, which it is, 1/2 times 2 over 1, when you multiply fractions, because that's really a 1 there, it becomes 1 times 2 is 2, 2 times 1 is 2, 2 divided by 2 is 1. So when x is 2, y is 1. So we can plot these 2 points, 0, 0, and 2, 1. All right, so 0, 0 is there. 2, 1 means you're going to come over 2 on the x and up 1 on the y. So you got your 2 points. Feel free to use the tool in Alex, or if you're using your debit card or a credit card or some sort of business card as your ruler, I find it pretty handy, then you can just connect your dots just like that. Let's try another one that's kind of got that tricky little fraction in here. Just remember my trick. If you have a fraction, choose the denominator as your x coordinate, or your x, I shouldn't say coordinate, I should say x value to substitute in. Okay, that's probably better. All right. So of course I have another example that's got that icky fraction in there. It's okay, we're gonna sort it out. Please pause the video and give it a try yourself first, and then come back and see me. Okay, so hopefully you started off by putting a 0 in for x. 0 is such a wonderful number because anything times 0 is 0. So we've got a coordinate of 0, 0, which is that special origin. Okay, this has a fraction in it, so I'm going to feed basically into the x part of the coordinate a 2. Whatever's in that denominator, I'm going to give it to be x. So y equals 3 over 2 times 2. Well, you have to figure out what 3/2 of 2 is, but that's kind of hard to kind of think through. So just do this, 3/2 times 2 over 1. Go straight across. 3 times 2 is 6. 2 times 1 is 2. 6 divided by 2 is 3. Isn't that beautiful? Or you could just say to yourself, that cancels and the answer is 3. Depends on how you want to attack that. So 2, 3 means I'm going to come over 2 hops to the right on the x-axis 2, and up 1, 2, 3 on the y-axis. Okay, so I got my line looking all cute. Okay. All right, I'm going to end this video right here, and then we'll start again in the next video on the next sets of concepts in week 11. See you soon.